Okay, so hello. Now that the meeting is now being recorded, hello and good afternoon, everybody. Welcome again to CE3221 Principles of Reinforced Concrete. For today's meeting, we will just be discussing about the design process of our reinforced concrete structural members in reference with the National Structural Code of the Philippines. So I will just be confirming if it is really recording. Okay, so nagre-record talaga siya. Before proceeding, everyone, do you see my laser pointer?
Yes, sir.
Yes, sir.
Okay, so very good. So once again, we will be discussing about the design principles and the design process of our reinforced concrete in reference with the National Structural Code of the Philippines 2015 edition. So with that, kasasabi ko lang, the main reference for our subject will be the National Structural Code of the Philippines 2015 edition, Volume 1, 7th edition, second printing. Kasi meron tayong first printing and meron din tayong second printing. And yung latest is of course yung second printing. So yun yung reference natin for our subject and for the remainder of this course. Okay, so these are to be the following steps in designing our concrete structure. So we have your preliminaries. We also have your preliminary design, followed by your determination of loads, your analysis, selection of section, drawing and detailing, bid and quantity surveying, and project construction itself. So let's have a little bit of a glimpse on the definition of all of this, no? So when we say preliminaries, it is to be in this step or it is to be in this process wherein the designer will know the parameters needed for the design. So like yung length, no? So for example, the length of each of the structural members. So it is already included here. And then the limits of the sizes of each member as per the structural plan. I mean, as per the architectural plan, I should say. So for example, according to the architectural plan, that a certain column should not exceed 400 mm by 400 mm. So with that, guys, so easy peasy lemon squeezy, what that means is that hindi kayo pwedeng lumagpas ng 400 by 400. So that is to be in the preliminary part or the preliminary. So once again, it is to be in this step wherein the designer will know the parameters needed for the design as per its limits and whatnot. And after your preliminaries, you will now be going through the preliminary design. And as per the name itself says, it is to be in this process where we would be choosing an initial section property. And it is to be the section that we will try. So, gagawa tayo ng section dito na initial, then it is to be the section that we will try if it is already adequate or if it is already structurally economical. And if not, ayun, tsaka tayo kukuha ng bagong section. Okay, so after your preliminary design, you will now be determining the loads or the determination of loads. Okay, so it is in this step where we will be solving for the magnitudes of the loads that will be subjected to our structure. So this is basically the reason why we engineers design our structures, because of loads. Because of loads, the loads are to be the reasons why our structures fail. So we have different types of loads. So we have our dead loads, we have our live loads, we have our wind loads, our earthquake loads, roof live loads, earth loads, and so on and so forth. So we also have our vertical loads and horizontal or the lateral loads. And as per its definition, I will be posting a pre-recorded video lecture for your reference about the different types of loads. Okay, so once again, it is to be in this step wherein you would be solving for the magnitude the magnitude of the loads that will be subjected to your structure. And once that you already know the loads that will be subjected to your structure, you will now be analyzing your preliminary section. And it is to be in this step where we will be checking the initial section if it is to be adequate, if it is to be inadequate, or if it is to be over-designed. So if it is to be adequate, if it is to be failing, or if it is to be over-designed. So kung sumusobra siya. Then after your analysis, so basing it from your result, if it is to be adequate, inadequate, or over-designed, you will now be selecting another section if needed. So for example, that if it is to be adequate already and if it is to be economical already, then your preliminary design or your initial section is to be the one governing. So yun yung pipiliin mo. But for example that your section will fail, then you must choose another one. So choosing another one will go back to here. Will go back here in the analysis part. Then you will be analyzing it again. And if it is already adequate and it is already economical, then that is to be the section that you will be choosing already. So ayun siya. So stay put guys, I will be explaining in detail later and maybe I will explain it in Filipino or Tagalog if you may, if that is to be the measure that you will be understanding our lesson better. Okay, so that is for the selection of section. And once that you have already selected your section, you will now go through the drawing and detailing. So once again, after finalizing your section, the design engineer or you will now be interpreting the design through drawings and will now be placing them in your structural plans. So a structural plan is a piece of paper or a piece of, a plan that shows the detail of the design itself or the results of the design. So after drawing and detailing, you will now be you will now be computing its costing through here. So bid and quantity surveying. And as far as I know, all of you here have quantity surveying subjects. So it is to be in that subject wherein you will now be computing for the project cost or the cost per whatever you are building. So it is to be here. So after determining the cost of your project, of course, you will now be constructing the project itself. So these are to be the design process if you are to build reinforced concrete. So guys, understood? Malinaw? Is it clear? Speak guys. Oh, Miss Akop. Clear?
Yes, sir.
Okay, very good. Miss Baklili, clear?
Clear po.
Very good. How about for Miss Trinidad? Clear?
Yes, sir.
Okay, very good. Mr. Pineda, okay? Okay, mawala si Mr. Pineda. Mr. Rosete, clear?
Yes, sir.
Okay, very good. Okay, so moving forward. So basically, guys, this is to be the summary of the design process in flowchart form. But it is, according to this table, according to this flowchart, the preliminaries was already removed. So, meaning that this is to be the design process after your preliminaries. So, in your preliminary design, so once again, I will just be repeating all of this. So, in your preliminary design, you will now be choosing an initial section. So, for example, in your initial section, you want it to be, let's say, 250 by 400. So, this is just an example. So, let's say that this is to be your initial section. So once again, let's say that this is to be 250 mm by 500 mm. So once again, this is just an example. Okay, so after your preliminary design and after knowing the magnitude of your loads, you will now be checking this section if it is already adequate. So you will be checking it at this part or the analysis part. Then if it is, after analysis, you will now be checking its response to the loads. So it is to be in this step wherein you will be knowing the deflection and its limits. So, ayun, meron tayong mga ibang parameters sa deflection na kailangan yung i-check kung pasok siya. So, okay. By the way, wait. Okay. So, after your response, so after checking if your member is to be adequate in, let's say, bending or let's say compression, then after which, you will now be checking its deflection. Then after which, once again, you will now be checking the section overall. So, i-check nyo kung pasok itong 250 by 500 natin, no? So, for example, that it is adequate already and it is to be economical, then you will be proceeding to the drawing part already. Pero for example, that your section here fails. So for example, kulang yung section natin na to. So we will be modifying our design. So maybe let's increase the depth. So maybe in your modification, you have increased the depth by 50 mm. So for example, I will be erasing this. So for example, that your section is now to be 250 by 550. Okay, so once that you have already modified your design, you will go back to the analysis part, then the response part, then you will check if it is to be adequate already, or if not, you will go modify your design once again. And if you are already satisfied with your design, if you think that it is already economical, then ido-drawing mo na siya ngayon. So you will be drawing it already. So guys, do you understand the flowchart? Mr. Sinong, did you understand the flowchart?
Yes, sir.
Okay, very good. How about for Mr. Basalo? Did you understand the flowchart?
Yes, sir.
Okay, very good. Aubrey? Joanna? Understood?
Yes, sir.
Okay, very good. Okay, so there before proceeding to the designing part itself, so we actually have these different design codes and specifications. But can I get a confirmation, guys, that these texts are readable? So readable ba itong mga nakatype dito?
Yes, sir.
Okay, very good.
Yes po.
Okay, so once again, these are to be the different design codes and specifications that we will be using in our subject. Okay, so first up, we have your ACI, and ACI stands for American Concrete Institute. So this is actually the reference code for your NSCP when we are to talk about concrete, so reinforced concrete. So once again, your NSCP is actually referring to ACI. And in this particular subject, we will be referring mainly to the code of So ACI 318-14M. Okay, so this is to be our main reference for our subject, or ACI 318-14M. So if you would be seeing this code, so ACI 318-14 without the M, so they are basically the same. So this code at the top is basically the same as for this code. But if you would be using this code at the bottom without the letter M, this indicates, this code is actually in terms of English units. So naka-inches siya, naka-feet siya, and whatnot. Since the code is to be an American Concrete Institute code, so if it is to be an American code, its default units would be in English. So naka-inches siya, naka-feet siya, naka-kips siya, naka-poundal force siya, and whatsoever. But since we are in the Philippines and we use metric units as our base units, we would be using this code. So once again, ang pinagkaiba lang nila is that this code on the top, at the top, is to be converted already to metric. So instead of using 1 inch, in this code, they use 25.4 millimeters. So guys, do you understand the difference of the one on top and the one on bottom? Understood the difference? Miss Baklili?
Yes, sir.
Okay, very good. Okay. Jezreel, understood?
Yes, sir.
Okay, very good. Okay, so moving forward, so aside from our American Concrete Institute, we would also be referring to AASHTO. And the AASHTO stands for the American Association of State Highway and Transportation Official. And as per the name itself says, this is mainly on state highways or the horizontal projects. So in this course, which is the principles of reinforced concrete, though we would still be using this, but we would use it rarely. So we would be referring to ACI more. And we also have our AREMA, and this stands for the American Railway Engineering and Maintenance of Way Association. So these are to be for your railways. So easy peasy lemon squeezy. Then as for the fourth code, this is to be UBC/IBC, or the Uniform Building Code or the International Building Code. So basically guys, this is to be the reference of NSCP in terms of seismic loads or yung earthquake loads natin. So if you would be referring to NSCP in solving for your earthquake loads, you are actually referring to the code by UBC or IBC. So once again, yung earthquake loads natin sa NSCP, naka-refer siya sa UBC. So this UBC and IBC right here is already incorporated to our NSCP as well as for our ACI. So okay. Okay, so proceeding guys. So when we say structural designing, so I will just be typing them here. So structural designing. So for a while. So structural designing. Okay, so when we say guys structural designing, if you would be searching for its definition in Google, you would stumble across so many definitions. But in a nutshell guys, to put it simply, structural engineering is to be the engineering process by which the designer finds out the safe and economical specs of a structure sufficient to withstand loads. Okay, so I wouldn't be writing them any longer here, but I would be explaining it in a different point of view. So I will just be downloading a certain image from Google Image. So for a while. So I will be posting a picture of a chair. For example. So ano ba magandang share dito? Okay, so I choose you. So for a while. So, oops, sorry. So credits to I Heart Crafty Things. So itong website na to. So for example that we will be having a certain chair. Or let's say that we have a certain person and a certain person weighs, let's say, 80 kilograms. So 80, oops, sorry. Ayaw ng pen ko. So once again, for example, we have a certain person weighing 80 kilograms. So 80 kilograms. And if he is to sit in a chair, we must choose a chair that has the capacity of 80 kilograms and higher. So once again, if this is to be your chair, the capacity of your chair should be greater or equal to 80 kilograms. So this force right here should be 80 kilograms and above. So let's say that you have a certain chair with a capacity of 120 kilograms. So if the chair has a capacity of 120 kilograms, it means that it can carry this particular person. But for example, that the capacity of your chair is to be 70 kilograms, since it is to be lower than 80 kilograms, it means that your chair is to be inadequate. Kasi nga, 75 kilograms, 70 to 75 kilograms na yung capacity niya, and ang bubuhatin niya 80 kilograms. If that is to be the case, then it will fail. So for example, once again, that your chair has a capacity of 140 kilograms, then it means that it can carry this particular person. Kasi nga yung capacity niya, 140 kilograms. So before proceeding guys, did you understood the concept here? So basic concept lang naman siya, no? Wendell? Understood? Okay, very good. Verlin? Understood?
Yes, sir.
Okay, very good. So that is basically where we would be going. But take note, guys. So if you would be seeing this one right here, so 140 kilograms and 80 kilograms, so at first glance, you would choose 140 kilograms. Siyempre, mas matibay yung 140 kilograms na capacity ng upuan as compared with your 80 kilograms. Mas matibay siya. So ano naman na yon? Self-explanatory na. Kasi nga, yung capacity niya 140 kilograms, then itong upuan na to, yung capacity niya 80 kilograms. But take note of this particular figure right here. So it is to be in this figure, so sabi sa figure na to, that the higher the cost, the higher its safety. So in other words, the stronger a certain structural member is, the more costly it is or the more expensive it is. And the less the cost it is, the less the cost, the higher the economy. And the higher the economy, ibig sabihin doon, mas nakakatipid ka. So if you would be choosing 140, the chair that has a capacity of 140 kilograms over the one that has a capacity of 80 kilograms, this particular chair right here would be more expensive. So mas mahal of course yung mas matibay. So with that, if you would be going once again here, the stronger the structural member, the more expensive it is. So ayun, pero ang gusto naman natin since we are engineers, it should be safe and it should be economical. So with that guys, we should meet at an optimum point. So by optimum point, this is actually the design wherein it is both economic and safe. So dapat itong dalawang to. So with that guys, so eto, kapag nag-meet siya dito, so itong point na to, hindi siya gaanong mahal and safe siya pero hindi naman siya yung sobrang tibay. So for example, in this particular example once again, if you are to be carrying 80 kilograms, so it is if it's optimum weight, it's the optimum chair that you will be buying is to be the one that has the capacity of 80 kilograms. So yun yung perfect, no? So yun yung pinakatipid yet safe. Because if we would be buying an 90 kilogram chair, a chair that has a capacity of 90 kilograms, mas mahal siya as compared with the chair of 80 kilograms. But if we would be going lower than 80 kilograms, so let's say that we will be buying 70 kilogram chair, or let's say 78, masisira na yung upuan natin kasi nga 80 kilograms yung uupo. So guys, did you get the point? Mr. Talakan, did you get the point?
Yes, sir.
Okay, very good. Mr. Atiwag, did you get the point? Okay. Nag-on ka ng mic pero wala akong narinig, but yeah, I saw you opening your mic. Anyway, so how about for Miss Egaran? Did you understand our point?
Yes, sir.
Okay, very good. Okay, so once again, that this is to be, we would be having an optimum point. So once again, if you say structural designing, hindi yung pinakamatibay yung pipiliin mo. Kasi yung pinakamatibay, mahal siya, of course. In structural engineering, you will be choosing a section that is to be safe, but not very expensive or still economical. So once again, safe and economical. So that is structural engineering in a nutshell. And speaking about structural engineering, these are to be the general requirements or the design philosophy. So it is said here that, by the way, I will just be resizing this for you to see it better. Okay, so according to this one right here, that the design strength should be greater than or equal to the required strength. So your required strength in our example right here, so ito, ang required niya, since ang taong nakaupo dyan is 80 kilograms, so your required strength is actually your load. So I will just be writing them here. So in our example earlier, that our required strength is to be 80 kilograms. So this was the weight of the person earlier. So weight of person sitting on the chair. And it should be less than or equal to the design strength. And when we say design strength, this is to be the capacity of your member. So if this is to be 120 kilograms, so for example, ito yung lakas ng upuan natin, no? So ito yung capacity ng upuan natin. If it is greater than or equal to 80 kilograms, then our section passes. So okay siya, pasado siya. However, if it is to be less than 80 kilograms, so let's say that the capacity of your chair is, let's say, once again, 79 kilograms. So this is now to be erroneous. Thus, your section is now inadequate. So it would be as simple as that. So once again, that the capacity of your structure should be greater than or equal to the required strength. So, basic siya, no? Kung ako, may bubuhatin akong bagay. So, for example, may bubuhatin ako. And yung kaya ko lang, let's say, is to be 100 kilograms, for example, ibig sabihin, hindi ko na mabubuhat yung 105 kilograms kasi yung limit ko, 100 kilograms. Pero, kapag magbubuhat ako ng mas magaan na bagay, for example, 50 kilograms, of course, kaya ko siyang buhatin. So, that is basically it. So, that is to be our basic design principle. However, we have a certain catch here. So, erase ko lang muna ito. Ay, hindi, wag na pala. Tsaka ko na erase. So, once again, we have a catch here. In the analysis, design, and construction of structures, we will inevitably face some uncertainties. So, for example, meron tayong uncertainty na the actual load may vary. So, for example, in this particular example right here, so the weight of the person is to be 80 kilograms. Suppose that, well, we will be designing the chair to have a certain weight of 80 kilograms. So, for example, dinesign natin siyang 80 kilograms. So, what if that this particular person went to Mang Inasal and ate 15 cups of rice that day? Then maybe his new weight is to be, let's say, 83 kilograms by the end of the day. So, that is one uncertainty. So, once again, the first uncertainty is that this particular load right here might be different. So, baka nag-iba yan, baka dumagdag yan ng onte and whatsoever. So, that is one uncertainty. So, another uncertainty is that maybe during the manufacturing of the material, so in this case, for example, nung bumibili ka ng upuan, yung nabili mong upuan dito is medyo pangit yung kahoy. So, ayun, kapag nagpangit yung kahoy na nabili niya, of course, bababa yung quality and bababa yung strength niya. Or maybe, let's say, when you are to buy a certain chair, and let's say that the diameter of its foot or its feet, so for example, bilog yung mga cylindrical yung mga paa niya. Let's say that in the design, in the construction part itself, lumiit, siguro 0.1 inches too short siya. And by that itself, guys, nag-iba na yung strength niya. So that is another uncertainty. And another uncertainty of it is, for example, that you are installing this, then medyo na itabingin nyo ng 1 degree, no? So, kung na rin ang itabingin nyo yung pag-construct niya ng 1 degree, of course, mag-iiba na agad yung strength niya and hihina siya. So, those are to be some of the uncertainties in, of course, designing a certain structure. And for us to address So for us to address those uncertainties, we will now be adding factors of safety. And by that, guys, so I will once again be erasing this. So once again, we will be applying factors of safety. So for example, that your member is to be a flexural member. So ito. So, for example, that we will be having a certain moment. So, let's say that this is to be moment MU. So, this is to be the ultimate moment, for example. We will now be decreasing the design strength. So, let's say the design strength is to be nominal moment or MN. We will now be applying a reduction factor here. So, phi. So, for example, once again, in our example earlier, that let's say the MU is to be 80 kilograms. So for the MN, so for example, the true strength of that chair is to be 80 kilograms. We will now be reducing it for a factor of safety. So for example, this is now to be equal to 0.9. Just for pretend, guys. So 0.9 times 80, so this is to be 72 kilograms. So 72 kilograms. And is it greater than or equal to 80 kilograms? So it is not. So meaning that this particular section is inadequate. However, in real life, so kung sa totoo lang, pasado siya kasi nga 80 kilograms. But due to uncertainty, bawasan natin siya ng strength para kunwari para meron tayong factor of safety. So that is how we would be addressing the uncertainty in your strength. But how about for the uncertainty in the loads? So like what I have said earlier, na paano pag etong taong to, kumain siya sa Mang Inasal and medyo kain siya ng madami and let's say tumaas yung timbang niya. So for us to address that issue, we will now be applying factors here. So for example, that if that is to be your dead load, we will be applying, let's say, 1.2 here. So it will depend, no? So ayan. So those are, these factors, this one and this one, are to be, are measured in order for us to address the issue of uncertainty. So ayun lang yon. And speaking of load combinations, loads. So for example, ito no, nagdagdag tayo ng 1.2 na factor dito para tumaas to. So in this case guys, so for example no, erase ko lang itong part na to. So let's say that this is to be a value for our Mn. And our Mn is to be the strength of our share. So Mn is to be greater than or equal to, so cross-multiplying this. So cross-multiply natin to, or better yet, if you would be dividing both sides by 0.9. So that so that Mn will be left to the other side. So Mn is now to be, so greater than or equal to, so this one would cancel out, so 0.9 would cancel out, and solving the one at the right, so looking at the calculator to your left, 1.2, sorry, isa pa. So 1.2 times 80 divided by 0.9, and it is to be 106.6, so 106.6 kilograms. So with that guys, ibig sabihin neto na dapat yung capacity ng structural member mo should be greater than or equal to 106.6. So that is to be it. And ang tawag dito sa design proper na to is to be strength design. Or in concrete, this is to be the USD, or the ultimate strength design, or the ultimate stress design. Okay, so before proceeding, naintindihan ba? Roxanne, understood? Roxanne, are you there? Did you understood our lesson? This idea? Okay, mukhang wala si Roxanne. How about for Chandni? Did you understand?
Yes po.
Okay, very good. How about for Giovanni? Understood?
Yes, sir.
Okay, very good. Nash, understood?
Yes, sir.
Okay, very good. Sherilyn, understood?
Yes po, sir.
Okay, very good. So once again, magdagdag tayo ng factor para ma-address natin yung uncertainty natin. And speaking of uncertainty, so these are to be the uncertainties for reinforced concrete. So number one, that is your, actual loads may differ from those assumed. So parang sinabi ko siya kanina, na paano pag nag-iba yung naging loadings natin. So this is for our first uncertainty and others. So I will be giving you notes about this, and if kung gusto nyo nang kopyahin to, pwede nyo namang i-screenshot, pa-SSD na lang, di joke lang. So you can screenshot this or, well, memorize nyo, kayo bahala. So number two, the actual load may be distributed in a manner different from that assumed. Self-explanatory. Then for number three, the assumption and simplifications inherent and etc. Basa-basahin nyo na lang yan. And ito pala, no? So reinforcement may not be in its proper position. So if we would be drawing, let's say, a certain section. So for example, that this is to be your section. For example, that this is to be your section. And we will be placing a rebar here. So a reinforcing steel bar here. A reinforcing steel bar here. 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 And here. But what if during the construction proper nung ginagawa na siya, yung placement mo nitong bottom bars medyo naitaas mo ng onte. So for example, napunta siya dyan. And if that is to be the case, of course, the nominal moment or the strength of your material will not be the same anymore and will be reduced. So once again, so that is one uncertainty here. So once again, for us to address that uncertainty, we will be applying some safety factors. So reduction factors and for our load combination. And speaking about load combinations, so these are to be the following load combinations as per NSCP 2015 page 4-34. So if your primary load is to be a dead load, its factor is to be 1.4 dead load. And if your primary load is to be live load, so eto. So your load combination is to be 1.2 times dead load plus 1.6 times live load plus 0.5 roof live load or rain load. So there, and as for this one right here, this is to be 1.2 dead load plus 1 wind load plus 1 live load plus 0.5 roof live load or rain load. So it is not a requirement for you to memorize this because we don't know, maybe in the succeeding codes mag-iba sila. But if you can memorize this, then better. But if you cannot memorize this, as long as you have your NSCPs with you, you're good, you're fine. So ayun. And actually ako, hindi ko naman talaga to memorize dati, but as time goes by, as time went by, na-memorize ko na siya unwillingly, no? So na-memorize ko na siya dahil sa kadi-design ko. So ayun. Okay, so load combination. So ito yun na yan. Kung ano man yung result na yan, yun na yung magiging required strength natin. So for example, that you have solved for the moment, so MU na yan, MU. For example na ang sinosolve nyo is shear, that is to be VU. Kung ang sinosolve nyo torsion, that is to be TU. And so on and so forth. Basta yung main niya na equation is to be the following. If you would be referring to NSCP 2015, page 4-34. And once again, this is to be in reference with ACI 318-14. Don't forget the M since we are metric. Okay, so those are to be the load combinations. So, eto siya sa part na to, sa right. Dito. So, it is to be at this part. But what about for the reduction factor here or the reduction factor for our design strength? So, for the reduction factor for our design strength, it is to be given by the following. Guys, I'm not quite sure. Can you read this once right here? Is it still readable? Or not anymore? Chandni, is it readable in your part?
Opo, sir.
Okay, very good. How about for Wilmel? Is it readable in your part? Wilmel? Babasa ba siya? Okay, mukhang wala. How about Frederick?
Yes, sir.
Ay, okay,
Yes,
very
sir.
good.
Yes, sir.
Okay, so kung readable, so these are to be the reduction factors phi. So for your moment, axial force or combined moment and axial force, that will range from 0.65 up until 0.9. So ito yung range natin ng reduction factor if your structural element is to be a flexural moment element or an axial element. So these are to be for your beams and for your columns. Okay, so moving forward, if your structural element is to be subjected with shear, so yung shear niya, or yung shear capacity niya is to be reduced by 75%. Thus, you will be multiplying 0.75. So, for example, ang sinosolve mo, or let's say for example, ang sinosolve mo dito, so for example, ito, sinosolve mo dyan is shear. So, for your shear, that is to be VU. So, VU. So, that is to be the required strength. And for your design strength, so this should be less than or equal to what is to be your design strength. So your design strength is to be the nominal strength or the Vn. So Vn stands for the nominal shear strength. And you will be multiplying it by your reduction factor. And since this is to be in shear, so for shear, you will just be multiplying it by 0.75. Meaning that you will only use 75% of the load. So, 0.75. So, ayan lang siya. And if it is to be in terms of bearing, then you will be multiplying it by 0.65. So, meaning you will only use 65% of the nominal strength of it, and etc. So, the list will be from NSCP 2015 page 4-140. So, ito, puntahan nyo na lang yan kung gusto nyo makita itong mga to. Okay, so anyway, so as you can see here, guys, that for your moment, axial force or combined moment and axial will range from 0.65 up until 0.9. So, paano nyo malalaman kung 0.65 or 0.9 yung gagamitin nyo? You will now be referring to this. So we will be having a detailed computation of this maybe next meeting or the next pre-recorded video lecture. Basta sa susunod na siya. Kasi feeling ko medyo pagod na kayo ngayon. Anyway, so for example that your concrete is to be compression controlled. So if it is to be a spiral member, then you will be using 0.65. And for others, you will be, 0.75. And for others, you will be using 0.65. And if it is to be tension controlled, so if your reinforced concrete section is to be tension controlled, which is to be a much better control factor, you will be using 0.9. And as for the transition part, kapag nandito sa part na to, you will be using this formula at the bottom part. So ayan, gagamitin lang to. And once again, as per its detailed computation, we will be solving for them next meeting or maybe next pre-recorded lecture. So ayun lang, in today's meeting, I would just want you to know how the designing works, paano yung steps. And as per its detailed steps and as per its computational steps, tsaka na yun. So that will come after. So once again, for our design process, what we will be doing here is that mamimili muna tayo ng section na isa. After preliminaries pala to, no guys? So, sige, Tagalogin ko na lang. So in your preliminaries, dito nyo malalaman kung ano yung limit ng mga section nyo. For example, ang limit lang niya is to be 400 by 400 lang. Ibig sabihin, hindi ka na pwedeng lumagpas doon. So that is for your preliminaries. And next up, dun sa preliminary design natin, ngayon, mamimili na tayo ng section na itatry natin kung pwede. So kapag namili na tayo ng section, ngayon, isolve na natin ngayon yung magnitude ng loads na bubuhatin ng section. So once again, I am speaking in Tagalog para mas maintindihan nyo, no? Sa iba sa inyo. So if you prefer English, replay nyo na lang yun dun sa English part. And if you prefer Tagalog, then this is your time. Okay, so yun, ulitin ko lang. Sa preliminary design, mamimili ka lang ng section mo. Then for your determination of loads, you will now be computing for them. Tagalog nga pala. Iko-compute nyo na dito yung magnitude ng loads natin na ilalagay natin sa structure. Then sa analysis part, guys, i-check nyo dito sa analysis part, sa analysis proper na to, if yung preliminary design nyo is pwede na. Or kapag over-design ba, or kapag kulang ba. Kapag inadequate siya, lalakihan mo ngayon yung section mo. Kapag over-design siya, liliitan mo ngayon yung section mo. So, in your reinforced concrete, this is a matter of trial and adjustment. So I do not want to use trial and error na word, no? Though they are basically the same, pero mas gusto kong gamitin yung term na trial and adjustment kasi i-try natin, then i-adjust natin hanggang makuha natin yung optimal or yung optimum natin na section. Then, if you have already chosen your section, so ito pala siya, no? So mamimili ka ngayon ng section. So kapag nakapili ka na, i-drawing mo na siya ngayon sa structural plan. So after mo siyang i-drawing sa structural plan, so basing it from your structural plan, i-compute nyo na siya ngayon sa quantity surveying. So di ko alam kung sinong quantity surveying nyo, baka si Sir Cabanlig or sila Ma'am Sanchez and etc. Basta yun, i-compute nyo na ngayon kung magkano, basing it from your drawing and detailing. And kapag nanalo kayo sa bidding, kapag nakuha nyo yung project, gagawin nyo na siya. So our design process is to be as simple as that. And in this subject, we will mainly focus on this. So preliminary design up until the drawing and detailing. So we will be focusing on these steps throughout our course. So, okay, understood? For those who understood our lesson, speak.
Understood po.
Yes, sir.
Very good. Okay, how about for the others?
sir.
Yes, sir.
Yes,
Yes,
sir.
Yes,
Yes, sir.
Okay, music to my ears. Okay,
Yes, sir.
so very good. So guys, do you have any questions? So basically, that is to be our lesson for today. So tsaka na tayo mag-proceed sa computations part, no? Para yung start up until finish computation tayo para mas madali nyo maintindihan. So guys, Are there any question about anything under the sun as long as it is to be about our subject? Okay, so I will be counting down, no? So 5, 4, 3, 2, 1, 0. Okay. So if there are no more questions, I will now be ending the recording. So stay put, guys. So I will just be ending the recording.